right? I'm asking because we're not all in the same spot in our Algebra 2 classes. Did we do synthetic division on Monday?
Yes.
Okay. All right. Let's take a few minutes to make some connections, okay? So I'm going to go back and we're going to talk about just some numbers, not polynomials again, okay? I know we hit this briefly the other day and we're going to do it again. Okay, let's just use our example. Let's do, if we say we have 15 divided by 3. What does 15 divided by 3 equal? 5. Okay, what does that tell us? 3 times 5 is 15, okay? 3 times 5 equals 15. What else does it tell us? 5 times 3 is 15, okay? Oh, that's good. What else does it tell us? 15 divided by 5 is 3, okay? Would you say that 15 is divisible by 3 evenly?
Yes.
How do I know it's divisible evenly? There's no remainder. I heard it from someone, right? There's no remainder, right? Remainder equals 0. So that means that 15 is divisible by 3 evenly. Is 15 divisible by 5 evenly? Yes. Are 3 and 5 factors of 15? Yes. What does that mean that they're factors of 15? They go into 15 evenly. Right. So we know all this stuff using numbers. You learned this in elementary school, right? What we're doing with our synthetic division is we're doing the same thing, but with polynomials. Okay? So when I give you a polynomial of x squared plus x squared plus 10x plus 16. And I divide it by x plus 2. Okay, let's do the synthetic division on that. What are we going to put in the corner? Minus 2. Good. Okay, and then what goes along the row?
Line.
1. Good. 1, 10, 16. Excellent. Okay, so we're going to do our synthetic division. We're going to bring the 1 down, and then we multiply, and we get negative 2. And we add, and we get 8. And we multiply, and we get negative 16. And we add, and we get 0. Okay? Now that we did that, we have to interpret it. So we started off with x squared. Our answer, okay, write this in your notes. When we divide using synthetic division, the answer will be 1 less than the exponent we started with. Here we started with x to the second, so the answer is going to be x to the first. So this is 1 x to the first plus 8. Now there's no x, or it's actually x to the 0, but what's x to the 0? 1. It's 1. So we don't even have to put that there. So our answer is just x plus 8 with a remainder of 0. That's my remainder right there. Okay. So we did the division using synthetic division. Now let's figure out what that's actually telling us. It tells us that x squared plus 10x plus 16 divided by x plus 2 equals x plus 8. Okay, let me say it again. We did the synthetic division. That tells us that x squared plus 10x plus 16 divided by x plus 2 equals x plus 8. Now let's see if we can make some generalizations like we did before with just the numbers, right? So what does that tell us, right? When we did 15 divided by 3 equals 5, you told me that that means 3 times 5 equals 15. Can you give me a similar generality looking at the polynomials? Tell me something similar. Not quite. Not quite. 15 divided by 3 equals 5. Jaden, you need to be taking notes. 15 divided by 3 equals 5. And you told me that means that 3 times 5 equals 15. Well, this divided by this equals x plus 8. What does that mean?
X plus 2 times x plus 8.
There you go. Right. Now that we did that division, we know that x plus 2 times x plus 8 equals x squared plus 10x plus 16. Okay? Does everybody follow that? Okay. Is there a remainder? Is there a remainder? Everybody, is there a remainder? No, there's no remainder. So, are there factors? What are my factors? Look up here. What were my factors? So what are my factors of the polynomial? No. X plus 2, x plus 8. I know you don't like that x in there, but it's the same thing, okay? You don't like the x, but it's the same thing. Look, right? If I had, take the x's out of there. 16 divided by 2 equals 8, right? So that means that 2 times 8 equals 16. Take the x out of there. Look what it's doing, right? There's my factors. Oops. It's the same thing. It's just that now we have some x's in there. Okay? Look at another one. 34 divided by 2. What does that equal? 34 divided by 2. Come on, wake up.
16.
17. What does that mean? 2 times 17 equals 34. What else does it mean? 2 and 17 are factors of 34. Right? When we say something is a factor, it means it divides evenly, right? It goes into it evenly. All right? There's our model. Now let's put it to use in polynomials. X squared plus 12x plus 27 divided by x plus 3. Okay? Let's do this. Everybody do this on your own right now. Everybody do it. Yes?
I was going to ask the same way. So, how would it be like 12x when you bring it down, you just write 12?
Mm-hmm.
Do you write the x?
No. Okay, everybody needs to be doing it. Everybody needs to be doing it. Everybody. There. What's fine? What's fine? What's fine? Do you know how to do it?
That's X plus 9, right?
Yeah.
You put the x?
I think your mom took away my hat today.
Really?
No, it wasn't.
Wait, why? I don't even know. I was working 31.
Alright, we get it.
I don't think
Right?
Oh, really?
Shooting.
What's the meeting for?
They're getting extended time on my
I
test.
don't know.
Gotcha.
I'm confused.
They got it.
Don't do tabular. You got to use synthetic division. Yes, you absolutely do. You absolutely do. Hey guys, you absolutely have to use synthetic division. 1 plus absolutely, you need to use synthetic division. Absolutely, we need to use synthetic division. Yep, we need to
Show you how to do it.
I asked her.
1.
Do I add it too or not?
I know.
What?
The coefficient.
Do I bring the x down first? No.
12.
And what do I do the exponent and the 12? Or the x out?
Yes. Okay, here we go. All right. So what goes in the little box? -3. Okay. Now we're looking at the coefficients in front. The coefficients, those are the numbers in front of the x's. Right, Mark? Those are the numbers in front of the x's, right, Anna? So we have a 1. Wait, what's going on, gentlemen? We have a 12, and we have a 27. The numbers in front of the x's, okay? All right, so we're going to bring the 1 down. Does everybody understand where I got these numbers? Give me a thumbs up or a thumbs down. Mary, do you understand? Anna, do you understand? Thumbs up? Okay, so we bring that 1 down, okay? Now we're ready to multiply. -3 times 1 gives me -3. I put it right under the 12. Okay, and then we're going to add them. 12 plus -3 is 9. And then we multiply. We multiply, we add. We multiply, we add. We multiply, we add. Okay? -3 times 9 is -27. And we add them. You have to use synthetic division. Okay? That's our remainder. So what does this mean? X squared plus 12x plus 27 divided by x plus 3 equals, right? This started out as an x squared. We always go 1 less in the exponent. So this is 1x plus 9. Yes, you can write 1x. Yep. Okay. No, that would be fine. That's perfectly fine. Yep. Okay. Okay. So on your homework, we had a bunch of them that had remainders, right? So on your homework, you had things like 4x to the 4th minus 11x to the 3rd minus 22x squared plus 4x plus 7 divided by x minus 4. This was one of your homework problems. TJ, please be quiet. This was one of our homework problems, okay? So we're going to take the opposite. So we put a positive 4 in the little corner. Okay. And then we're going to list our coefficients. So we have 4, -11, -22, +4, and positive 7. Okay, we don't need those plus signs in front of there. Okay. Everybody understand where we got those numbers? Okay. So we start off, we bring the first one down. And then we multiply. 4 times 4 is 16. And we add. And then we multiply. And we add. And we multiply. And we add. And we multiply. And we add. Okay. Did we get a remainder?
No.
Yes, we did. Okay, let's see what we have here. Right? This equals, right? Instead of x to the 4th, it's going to be x to the 3rd. So we've got a 4 here. 4 x to the 3rd plus, now we're just going to keep going down in our exponents. 5 x to the 2nd minus 2 x to the 1st, but we don't have to put that 1 there, minus 4, and then we said plus a remainder of negative 9. That last number, if it's a 0, then there's no remainder. This last number, this is the remainder.
So it's like a 0, but like
No, give me a second, and I'm gonna talk about that. Okay, this is our remainder. Now, before I go any further with this, I want to go back up, and I want to give you another example using numbers instead of a polynomial. Okay, what if this was 35 divided by 2? How many times is 35 divisible by 2? Or how many times does 2 go into 35?
that's a remainder.
Let me make it an easier one. Let's do 13 divided by 2. How many times does 2 go into 13?
12 and a half.
No.
6 and a half.
It goes 6 times with a remainder of 1, right? Okay, now let's talk about this. Does 2 times 6 equal 13? No. So are 2 and 6 factors of 13? No. So if I do 2 times 6, what do I get? 12. But if I add the remainder plus 1, I end up with 13. Everybody, I need you to all be looking up here. Okay, let me show you another one, right? Let's do 25 divided by 3. What is 25 divided by 3? 8 with a remainder of 1. 8 times 3, right? 3 times 8 equals 24. Okay, everybody paying attention? Because this is connecting it all, right? 3 times 8 is 24. Are 3 and 8 factors of 25?
No.
Okay, so 3 times 8 is 24. If I add the remainder, I get 25. Okay, let's go up to the polynomial. We have a remainder. So is x minus 4 times 4x to the 3rd plus 5x squared minus 2x minus 4. Does that equal this?
No.
No. But if I multiply them together, what do I have to do to actually get this? Add the negative 9. You have to add the remainder. Okay? Does everybody understand that? So this is how we check to see if they're divisible. So 4x to the 4th minus 11x to the 3rd minus 22x squared plus 4x plus 7 is not divisible by x minus 4. It doesn't go evenly. It's not divisible. Okay? Okay. So last night you did the practice of division. Today we're going to look at what we call synthetic substitution. And this is kind of cool because it's much faster than normal substitution, okay? So let's say that I have y equals 6x to the 6th plus 3x to the 5th minus 2. Everyone copy this down. X to the 4th plus 4x to the 3rd plus 2x squared minus 8x plus 10. Okay? Now, if I wanted to know, right, what does y equal when x equals 2? Okay? How would you do that? Plug it in. Plug it in, plug it in, right? What do? You plug it in. You'd plug the x in. You plug 2 in for all of these. That's what you would do. Okay? Now, that's a pain in the neck. 6 times 2 to the 6th plus 3 times 2 to the 5th minus 2 times 2 to the 4th plus 4 times 2 to the 3rd plus 2 times 2 squared. Anna, sit up, please. Thank you. Okay, that's a pain in the neck to do. Synthetic substitution is going to make that easier. So we're going to do the same thing that we did with synthetic division. Everybody should be writing this down in their notes. Yep. And this is the old way. That's the old way. Okay. Everybody should have it written in their notes. Okay, the new way. This is our new way, synthetic substitution. Now, we're going to make our box, or corner rather. Now, this is where it's different. When we were dividing, we took the opposite of that number and put that in our corner. Now, when we're doing the substitution, we do not take the opposite. We're just going to use the 2 the way it is. Okay? Everything else is the same. We're going to write our coefficients. 6, 3, negative 2, 4, 2, negative 8, 10. Everybody writing this down in their notes. Okay. Okay. We're going to do the same thing that we did before. The exact same thing. The only difference is that we're using the 2. We do not change it. We don't take the opposite. We use the number just the way it is. So we bring down your 6. And then what? Multiply. So we get 12. And we add 15. And we multiply. And we get 30. And add 28. Multiply 56. Add 60. Multiply 120. Add 122. Multiply 244. And then we're going to add. So this is going to be 236. And we multiply 12. So what's that? 472. And then we add 482. This is our answer right there. That's what we get when we substitute a 2 in there. If I had done it the old way, I would have gotten 482. Y equals 482. That's our answer. it is much quicker and easier than substituting it in. That's our answer. Okay?
So you don't do anything with the exponents anymore?
No, not when it's substitution. There's a difference. This is substitution. This is not division. This is substitution. So the only difference here, there's two differences. We do not change this. It's the number just the way it's written. And then all we care about is that last number. Okay, that's the only difference. Okay, you ready to try it on your own? Ready for your worksheet? Yes, please, Mrs. Mary, please. Huh? You're in the fan? Are you hot? You're always cold.
It's very hot.
You can turn that down to 72 if you want. I'm going to do number 1 with you.
Sorry?
We're going to do number 1 together. Okay, number 1 looks different, right? Number 1, we've got f of a equals negative 3a to the third minus 8a squared plus 2a minus 7. And we're doing at a equals negative 3. It says evaluate each function at the given value. Okay, so this looks different because in the example I gave you, I said y. Well, f of a is the same thing as y. F of x, f of a, f of b, it doesn't matter. It's the same thing as y. So what are we going to put in our corner? Negative 3. Okay, and then we list our coefficients. Negative 3, negative 8, 2, negative 7. All right. So bring down your negative 3, multiply, and then add, and then multiply, and add, and multiply, and add. Look how fast that was. There's our answer, negative 4. Okay.
Oh, wait, no, I didn't do it. I just did it.
See how fast that was? Okay, you can finish the worksheet. Yes, Jack. You can, but there should be plenty of room on there. Should be plenty of room. Plenteous. You can if you want to. Make sure you upload it to Google Classroom.